I think there's like 5 more minutes. We could probably wait before we actually start with the session officially. So, yeah, like one thing that I wanted to ask is, does everyone have some sort of Linux environment to play around with, to toy around with?
Yes, the mail has been actually sent to the registered candidates. So we really hope that
Okay,
all the registered participants would have actually installed it. Yes.
okay, okay. So, if anybody has not, like, if anybody was not able to install uh, some sort of Linux environment, there's like a lot of ways to do it, and I ended up like writing an article on it for this purpose, but I wasn't able to finish it due to time constraint. I'll probably publish that after the workshop because installing Linux is not the most easy work. So I just wanted to know if somebody is still not installed Linux. I'm having trouble in installing it. That's completely normal. That's completely okay. That's fine. The only question I have right now is, does everybody over here have some sort of way to toy around with Linux? It can be like on a virtual machine. It can be on something like some computer or like some compute instance you can get from the internet or anything of that sort. Like if people don't have access to Linux, any kind of Linux instance, uh, please do mention it on the chat. We can try doing something about it with the limited time we have. All right. I don't see anything coming from the chat, so I presume that everybody has some sort of way to interact with Linux.
Varun, Sona has
Yep.
came up in the chat. She says she has
Okay.
some
Yeah, she
trouble.
said that she's having trouble. Okay. There is some trouble installing it, but the question is, do you have some sort of like, even if you have not installed Linux on your machine, do you have some form of playing around with Linux, like in virtual machine or something? Okay, cool. All right. Do you have okay? Could you do one thing? Could you install what? Wait, I will share my screen. Um, is my screen visible? Hello? Hello, is my
Yes.
screen visible?
Yes.
Okay. So for those who do not have like any sort of thing to work around with, you could install multipass. It's a very easy way to get started with Ubuntu, and Ubuntu is what we're going to use for this session. So you can install this. But the only thing is, if you're using Windows 10 Home, if using Windows 10 Pro, it's fine. But if you're using Windows 10 Home, you also need VirtualBox along with it, and you can install VirtualBox from here, downloads. I think I already have a download. Yeah, VirtualBox and Multipass. I thought of like going through this whole thing in itself, but I realized that it's time consuming to show the installation process and stuff. So yeah, you can download it from here, and it's like 103 MB. So first, like VirtualBox will download. If you're on Windows 10 Pro or Windows 10 Enterprise or even Windows 10 Education, I don't think you need VirtualBox. Windows has its own thing to work with. But if you're on Windows 10 Home, you need VirtualBox along with Multipass. Yeah. Okay.
Okay, so we will actually
Cool.
quickly start the
Yep.
session right now.
Yep.
So,
Yep.
okay, now, okay, almost everyone has joined. So, good evening, all. A warm welcome to this Linux workshop conducted by Mixed Signals. As you all know, Mixed Signals is the electronics club of our college, and it aims to develop and nurture the skill set required by each and every one of you. Most importantly, all these sessions conducted would be of great use to all, including us, for our future projects and endeavors. So let me introduce myself first. I'm Tasneem Fathima MA. I'm the core member as well as the content head of Mixed Signals. I'm a final year student. Coordinators of this particular event are me, myself, and Helen. She's the publicity head of MS. So without any delay, let me introduce the keynote speaker of the session, Mr. Varun Krishna S. He's a fourth year computer science student of a college. MS is so glad that he has agreed to share his
I'm sorry
current.
to interrupt. I'm third year actually.
Oh, okay. So he's a junior, okay. Sorry.
Linux, it is something that you may not be able to do in like an operating system, like let's say Windows, right? So Linux actually is a very open ecosystem, and it is an operating system. And when you talk about Linux, it's not one thing. It's not like one operating system, right? It's rather a bunch or a collection of programs and software that runs together. And Linux is more aptly termed as GNU slash Linux, because Linux is just one component of it, the kernel component of it, which deals with all the process scheduling, the disk management, user management, and all that. But on top of that, there's a lot of GNU utilities, which is used along with Linux. So Linux is the bare essential minimum that is required to run, like the kernel is what is the bare minimum or essential required to run the system, without which you'd have a hard time in running a system. And like new utilities and programs run on top of this along with it rather, and you have a bunch of other open source software, and also you can even run proprietary software. Not that you can't run proprietary software, you have a lot of software that you can run on Linux, which makes Linux quite more user friendly. Linux in itself, the kernel in itself is very barebone, and there is it's about more about running the system rather than the user interaction aspect, or like running application programs, right? So now that said, Linux largely, okay, I'll just take some like maybe 30 minutes initially, or like around 40 minutes initially, to talk about Linux and to talk about how Linux sort of works, and then we probably we could move into the command line or the shell for that matter. So yeah, so I don't know if you might have heard of Unix. So Linux derives most of its, I mean, Linux is heavily inspired by Unix. And Unix was created in the 70s at Bell Labs, which I think came from AT&T. So Unix was like a very popular and powerful sort of operating system back then, and everybody was like trying to use it. But it was a proprietary operating system. Like you had to pay a price for it, just like every other operating system that existed back then in the 70s and the 80s. But it was very powerful. And the thing about Unix is that it brought along with it a philosophy. It brought along with it something people, I think, usually term as Unix philosophy, which is basically a concept of minimalism when it comes to programming and development, right? So the Unix philosophy is basically like uh, do something very small, but do that right and perfectly. Like instead of like make each program do one thing well, and like if you want to do something else, then make a different thing that does that job, instead of taking the thing and making it bloated or making it more complicated. So you have one task at hand, you create a program or you create a software or you do something to solve that program, and you do that really well, right? And it also has a lot of other things associated with it, as in like chaining and stuff like that, as in if you have the output of a program, that could be fed into the input of another program and so on. But I think at the very core of it, Unix philosophy has got to do with doing something, do that really well, and don't add unnecessary bloat to it. So that goes a long way into the philosophy, and that philosophy runs true even in Linux and a lot of development practices in general, rather than just Linux or Unix for that matter. So yeah, and yeah, so that is one of the core like Unix slash Linux principles. So if I go a bit into the history of Linux kernel, I think Linus Torvalds, the author and the BDFL, the Benevolent Dictator for Life of Linux, uh, was inspired by talk given by Stallman, and then he was like, he'll write an open source, like free software variant of this system called Unix, and that's how he was he was an undergraduate student or a graduate student, I'm not sure, just like one of us, and he was like, okay, today I'm gonna write a kernel, and that's how we started. So yeah, so that's a bit into the history of Linux, and then when Linux got too popular, GNU folks or GNU folks realized that okay, fine, instead of building our own kernel, we can make this Linux kernel, and then we can use the GNU utilities and programs, and then we'd have a rather fully fledged ecosystem or an operating system that people can actually use, right? So that's how GNU Linux came into picture. So Linux is rather not the most appropriate term. GNU Linux is a more appropriate term for the operating system. Linux is just the kernel, right? So why Linux? Okay. Why Linux? Because in Linux is completely free and open source. This means that you can go into their source code and see what's actually happening. You can understand whatever they're trying to do when you're trying to run Linux. If you want, you can try to compile Linux by yourself, and you can try to install every single component by yourself. You actually have you have a very clear understanding of what's happening, right? With something like Windows or Mac OS, it's not possible because these are proprietary. So that means that, like, these people might have come up with really optimized and well-performing systems, well structured. But at the end of the day, as a student, as a person who would like to know what is happening, there is no way for you to know without actually going and joining Microsoft, or without actually going and joining Apple and joining their operating system team or whatever, right? So it's like you're blind to whatever is happening inside, right? But with Linux, that's not the case. You can not just Linux. This is true even for like other famous open source operating systems such as like FreeBSD. But Linux is an operating system that's also free. Like, it's free as in you can go and inspect the code. You can try to understand what's happening. You can go and check, like, because the very development of the operating system is open. That means that you could probably go, if you are subscribed to their mailing list. They use mailing lists to communicate amongst themselves and make decisions. You can also know why a particular decision was made. Like, if this was something like Windows, like you do not have any understanding why this particular decision was made in the operating system, right? Like, their program managers might know it, their senior management might know it, but you as a student have very limited knowledge as to why they made a decision, or why they're using this particular protocol, or why they're using something, right? And they might have some vested interests, from the financial perspective. Linux is not like that, and it's a very free ecosystem, and that for a student, I think that goes a really long way, as you can really go how much ever deep if you want to. Like, let's say you're not happy with something in Linux, okay, you're welcome to fork it, and you're welcome to build on it. And whether they accept it or not is a different story, because they have to take into consideration a lot of things. But yeah. And what makes, like, there's like a lot of things in Linux. For example, there is system interfaces, there's processes, there's memory management, there's file system, there's like file system, disk storage and stuff like that. There's also networking, and there is essentially the human interface, like with like security and like stuff like that. And
Excuse me, sir. Have you shared your screen?
No, I was just talking about Linux at this point.
Okay.
Should I share
Yeah,
my
just
screen?
no. I just clarified.
Yeah, cool. Right, thank you. Also, feel free to give any feedback at any point of time. I'd prefer if this workshop was dynamic. I mean, if this were happening at college, I mean, I would have certainly preferred to see everybody's reactions and like get some sort of feedback. So any sort of feedback is welcome. Right. So this is Linux from a very theoretical perspective, but at the end of the day, when you want to install Linux, the thing that you want to look for is a distro. Again, so I have a half-finished article which I'd probably be, I don't know, sending it over, or like sending the link over or something, which talks about distros and like installing Linux. But if this were again happening at college, maybe like I could come and personally help you out. I mean, personally help you in installing Linux, but it's not possible. So yeah, if you're installing Linux, then like you might want to check out something called distros. It's basically a package version of like these components together. So like Ubuntu, Debian, Mint, these are all like really good generic distributions. And unless you're not into a particular niche, such as like let's say cybersecurity or like security, or some people might be interested in running servers. So those who are interested in security and stuff, they might be interested in installing a distro like Kali OS or like Parrot. Those who are interested in running servers, they might be interested in like running Red Hat Enterprise Linux or CentOS or something of that sort. But I'd suggest you to not worry about any of this. In the beginning, any sort of distro is fine. What's more important is you get to like you draw familiarity with the Linux ecosystem. Right. So at this point, I hope that everybody has sort of Linux machine that you have access to. So I think we could start by looking at the CLI. Does anybody have to say anything at this point? Maybe you could take a pause for questions, and like anything is fine. Any sort of question is fine. If you do not want to ask a question on the session, like with your voice or something, feel free to like put your question up on chat. Please feel free to give any sort of feedback too. So if you would like me to slow down, if you'd like me to clarify something, focus on something, anything of that sort, please do let me know either by raising your hand and speaking or like putting it up on the chat. Okay. Right. So I hope everybody's clear with Linux is at this point. Okay, shall we continue in that case? Give me some feedback. Okay, cool. Right. So I think I'll share my screen. Okay, somebody put up a question. Can you please explain once more about installation? Kuriakos, what is it that you expect me to explain about the installation? Is there something in specific?
I'm sorry, I was late by a few minutes, so I don't understand about that installation. I don't hear about it. Sorry.
Okay. Okay. Regarding the installation, I'll definitely have some links and like detailed thing coming up soon. But do you have access to a Linux machine currently?
No, I don't have access.
You don't have access. Okay. So in that case, I'd urge you to go to multipass.run, and then install their Windows binary. Also, are you running? I hope. I mean, I guess you're running on Windows currently.
Yes.
Yes. So you might also need to install VirtualBox. So install VirtualBox and like install multipass from multipass.run, and I think you should be good to start. Let me know on the chat if you aren't still done with it another 30 minutes or so. It might take some time to install this whole thing, but yeah, do let me know if it's still not done. Also, it would be really great if somebody could point out. Yeah, thank you. It would be really great if somebody could point out if something comes up in the chat, because if I'm sharing my screen, I might not be able to view the chat. Just saying. Cool. I think I'll share my screen in that case. It's I don't think I have the permission to share my screen.
Yes, you can share.
Yes, you can.
Okay. It says that you must grant permissions in order to screen share. Yeah, I don't think I can share the.
Previously, you had shared your screen.
Yeah, but I don't. I'm not able to now. I don't know. Is there any? It says that I do not have permission. Should I rejoin? Um. Okay, I'll try rejoining. I'm sorry. I think I was on mute. Can you see my screen now?
Yes, it's visible.
Yes, yes, now
Cool.
it's fine.
Okay.
Can you
Okay. I think
zoom
this
in?
some. Like there's nothing on the screen right now, but sure. I think. Is it more visible now?
Yes, yes.
Cool. All right. So, yeah. Okay. I think this like meet was glitching for a couple of minutes. All right. Okay. So I'm currently running Linux. I mean, I'm running Windows subsystem for Linux 2 version 2, and that's how I'm interacting with Linux. For anybody that's curious, and I'm currently primarily interested in like only the command line app. I mean interface, and that's solely what we would focus on for today, and we'd focus on how this ecosystem works in general. So the thing that you see right now, this particular application is it is Windows Terminal. It is an application by Microsoft. So what I'm trying to say over here is like people often get confused between terminal and a shell, right? So terminal and shell are two different things, and so this is actually not a terminal. It's to be, I think, to be technically correct, this should be called a terminal emulator, but so this is actually a terminal emulator. So what a terminal allows you to do is it gives you like an interface to talk to your shell or whatever thing you want. It's a graphical interface, but a shell is what you use to communicate, with your operating system or like Linux or whatever, right? And so shell is like you can think of it as a programming language which you can run, and this terminal is sort of a interface. It could be like a graphical user interface. Like this terminal is like very graphically oriented. Like it has settings and all that, and like I can even run another shell. So for example, PowerShell is Windows ka shell, right? And then there is something like Cloud Shell, Azure's Cloud Shell, Command Prompt. So these are shells, but I'm viewing these shells on terminal. So terminal is cool. All right. So let's get into what shell is. So shell, okay. How many? I don't know whether you might have heard it or not. There's this term called REPL. So REPL stands for read, eval, print, loop. So read. So you have some input. You read the input, then you evaluate the input, and then you print the result of this evaluated input, and then you loop. So basically, you take an input, you do some computation on it, and then you print the results of these, and then you repeat the process cycle. Right? So that is what the at the core of a shell is. It's essentially a REPL, right? So when you use Linux or anything of that sort, you might be seeing this shell called Bash, or some of you might have even heard of Bash, right? So Okay, when I type bash, what's happening is it's loading that shell, right? So now whatever I type into this is essentially a valid bash line or like a valid bash program. So I type ls. So this ls has got nothing to do with Linux, but I mean it has got something to do with Linux. There is like, but what actually happens is that bash takes this as an input, it's evaluating this, and then it's evaluating the output. So essentially it's a REPL, right? It's a read eval print loop. Cool. And you can, just like any other program, you can exit the shell also. You can use Control D and it exited the shell. The shell that I am using currently for my purpose, like for my personal purposes, is a shell called ZSH, right? And shells can be, like there are many shells. There is ZSH, there is bash, there is fish, there is TCSH, then there is, I don't know, corn shell. So a bash, again, for our purposes, we'll be largely focusing on bash. And bash and ZSH are largely similar. So, I mean, I'm going to be using ZSH, but I think for our use case, we're not going to encounter a lot of differences between the both. So we'll be using ZSH, but I don't, I mean, in the setup here, but I don't think that you might see the difference if you're running bash on your system, right? Right. So yeah, it's just another program. That's what I like to focus on. It's nothing complicated. It's just another program that you use to it. The only difference is that unlike a language like C or C++, these are interactive. These are interactivity is at the very core of it. These scripting languages. It's you can sort of like relate Bash to like Python or Perl. They're also scripting languages. The beauty of scripting languages is the familiarity and the sort of ability to interact with it. Like if you have a C or C++ program, you have to like take it, then you have to compile it, and then you have to run the executable, right? In any sort of scripting language, that sort of friction is removed. There is a runtime. You load that runtime before it starts, and then it is evaluated instantly and right there. So hence the name REPL, read, eval, print, and loop over this. So right. So currently I'm running ZSH. Okay. So yeah. Cool. Now let's look at the file system. So one more cool thing about Linux is that almost anything and everything is a file, right? Anything and everything that is there in Linux is a file, which is not how a lot of operating, and it's a very opinionated way that Linux took when it comes to operating system. Almost anything and everything is a file. So currently, I mean, in Bash, right? I mean, sorry, in the shell, it's ZSH, right? In ZSH, I'm currently at a particular file or a folder. To know where I am, I just need to use pwd, so that tells me where I am, right? So it says that I am in home and I'm in this thing called v19. So this is just the name that I use for my user. So in wherever you are, whichever directory you are in, whichever folder you're in, if you type pwd, it tells you where you are. So yeah, like basically, I'll just go through some commands so that you can navigate through these file systems easily, right? But before that, I'd also like to touch upon the help command. So any command in Linux that you have, right? You have like, for example, right now I give pwd. So along with pwd, I give a flag. We'll come to flag in a bit. That option. I don't know why that's happening, but like usually when you give wait, I don't know if this is a particular thing with bash. Yeah, so I think this is something to do with ZSH and bash difference. That didn't work in ZSH, but it worked in bash. So usually, and I think you should definitely use bash initially. You should even get into ZSH and stuff. Later on, if you're interested, you can get into ZSH and like stuff. But bash is a really good starting point. So like if you type pwd / space hyphen help, then you'll know what that particular command does, and it gives you the options, right? So with any command, you can give space hyphen hyphen help, and you'd get how that thing works, what it returns and stuff like that, right? Yep. So let's go into navigating around. Cool. So the very first command that I'd like to go into is ls, right? So ls basically says where, I mean, it lists, I think ls stands for list, I'm not sure. Yeah. So it lists everything in that particular directory or folder, right? So when you give, let's do ls help, right? Right. So it gives you all these options, right? These are all the options that you can use for ls. But it says it lists information about files and sort entries alphabetically if no particular, I mean, if these flags are not given or a sort flag is not given. You can, so you can see that it takes 2 arguments. So the thing about command line is that you give like a command, right? And then you have arguments and then you have options. So this particular thing is a very common pattern. You have a command, right? And then you give in a particular like you give some options, which is usually given in form of flags, which we'll come to in a bit. And then you give the arguments. The argument here is a file, but you can give any argument. It's just like any other function or like any other it's like a function in like a programming language, right? You can think of like it takes arguments and stuff. Very similar. So these are the flags ls can take, right? So if you give like lsa, then it shows like, hidden files. So in Linux, a hidden file is nothing but any file that starts with a dot, right? So these files, you can see a lot of these files with starting with dot. These are all hidden files. Usually they have something to do with things that you don't necessarily need to get into unless you want to like hack around with it or tweak it, right? So if I do like ls.yarn, so it says that, yeah, so this is one more thing. Like if you give ls along with the directory name, it will show what is in that directory. So if I say ls home, remember this is where we are currently, right? I'll just do this. I'll explain what that means. But so if you give ls plus a file name, it displays what is there in a file. As I told, everything in Linux is a file, which means a directory and a folder is also nothing but a file with a different type of file. We'll look at that in a bit. So I showed LSA showed hidden files, right? So let's say I give ls-l. So it shows something like this, right? Like this, all these file names that we saw here, right? Along with that, it also has like timestamps. It also has like something like we saw that this is my username. So you can use whoami command to know what your username is. So my username is vhawk19. So like it has something to do with usernames, and there is something here, like D, R, W, X, R, something like that, right? So I'm more interested in this aspect right now, right? So you notice all of these have, so this is essentially permissions, right? This particular thing says what permissions are enabled on these particular files, right? And the very first character of the permission thing is nothing but it says whether that particular file is a directory or not. Directory is nothing but a fancy way of saying folder. Like in Windows, folder is nothing but directory, right? So like now let's look at LSAL, right? So we know that A is used to denote hidden files, right? I mean, show the hidden files as well. And L is like to display all the other information as well, like permissions and stuff like that. When we do this, we get a more, the output gets bigger because obviously this is like way more stuff because I'm showing the hidden files. Now you can see that not everything has the same permission. There's like difference of permission, like, and not everything has, D in it. The hidden files that we had, Some of them do not have the D as the very first character, which means that that is not a directory. So, like, let's say it says that there is something called .zsrc, right? And there is no, like, it doesn't have D in it. So now let's try doing ls there. Dot, there's nothing in it, so it just displays that particular file name. But let's take something like, it says that there is bin inside it, and I have some. I think I have like I'm not sure if this color thing would be there everywhere, but I'm not sure if it's there in Bash. It should be there because that's what I'm seeing it. But like you should also be able to identify it with colors. Like I have some color, configured to show folders, I mean directories, and I have some other color to show like normal files, right? So I hope files and directories are clear, right? So okay, now ls is clear. Now let's go to cd, right? So let's do cd help, right? So it says that change the current directory to a particular dir. Dir stands for directory, right? So the default directory is a value of home shell variable. Okay. So this square brackets is used to mention like your options and parameter, I mean arguments that you pass, right? Okay. So yeah. So it basically changes the current directory to a particular dir, and it says the default dir is nothing but the value of home shell. So if you want to change the directory, like let's say let's do an ls. Now we know that these are the directories out here. So let's say I want to go into dot files, right? So if I say cd dot files, now as you can see here, I've come into dot files. I'll come into this symbol in a second. This symbol stands for tilde. It should be there somewhere above your tab uh, in your keyboard. We'll come to the symbol in a bit. But now we have reached dot files. If you do ls, you can see that it was not in the home folder. If you want to go back, you can do cd dot dot. Okay. So the default is to follow like this. Like, you need to worry about this. Dot dot is processed by removing the immediately previous path name component. There's nothing but like a fancy way of saying that, hey, if you give dot dot, you can go back, right? Now let's look at a couple of things. As in, let's try doing this. Sorry, let's try doing this, right? Does anyone have any idea what is going to come when I do this? I mean, what's going to happen when I do this? Feel free to like interrupt by raising your hand or by sending your answers in the chat. Okay, nothing is coming in so far. Cool. So we know that cd is followed by the argument to a directory. Exactly, it's the root directory. So what happens is that this is used to denote the root directory. So if I do this, and if I do an ls here, so I am finding all these directories which I did not create, because these directories were not created by me. This was created by the Linux while installing Linux. Or if you want, I can add a file here, right? Like I can say. Oh, okay, but like if I give it sufficient permission, I should be able to do it. Like I added hey here, but unless you know why you're doing something, it's usually a bad idea to put stuff in your root directory. I'll just remove that for now. Okay. Cool. So now if I do this, why remove write protected file? Okay. Is there something to do with permissions? I'm not quite sure. I'll have to look into it. don't worry about this. Yeah, cool. Now I have here remote. Again, see, I was talking about flags, right? The only thing I did here is essentially give a force. So hyphen F in some places is used to denote force. So I'm saying like I tried RM here, and when I wait, did I do RM first? Yeah, I did RM here, and then it said that hey, you could not do it, and when I did it, I just checked the output. Okay, I just checked if it deleted or not by doing an ls, and it was not deleted. And then I tried to force. So hyphen f is used to like force, and then when I tried to force it, it said that permission denied. So I gave it sudo. We'll get into all these now, but like you get the way you interact with it, right? So I usually don't interact with the root directory that much. So and unless you know what you're doing, it's not recommended to do it either. But if you have some particular purpose, if you want to do something like, for example, you might need to add something to the user, I think it's user system register or something. I don't know what the full form of user is, but yeah, or you might want to change a proc file, which is not usually recommended, but like let's say you want to do something, that's the beauty of Linux, right? Like you can come in and edit anything that you want. It might cause you a lot of trouble because you did something which you should not have done, but you're welcome to do whatever you want. Like you cannot do this in Windows. In Windows, like everything is in a state of like it's an executable thing, and you can't go and change source code or anything, right? Here you can change a particular thing, and like I mean, we can't change the source code here, but if you want, you can like download the source code and like modify something and recompile it and do whatever you want. Anyways, coming back to the point. Uh, cool. So yeah, so we've come to the root directory. So so as you can see now, it shows that this is currently the path I'm in. Now we see some things as home, right? Now let's do an ls home. So it says that there is something called vhop 19, right? So I don't know if you're used to or accustomed to like a multiple user setup on an operating system, but you might be, right? Like let's say you're running Windows, and let's say you're sharing this Windows system with your family. There might be like a personal, like there might be your own account, then there might be your sister's account or your brother's account, there might be something like a family account, or there might be a guest account, right? So a similar convention is also followed in Linux, right? Wherein you can have multiple users. So in your particular home directory within your root, you can have like multiple users. So this is one user. This is a user called vhop19. There could be another user called root. There could be another user called guest, or there could be another user called random user. You can create whatever user you want, and when you create a user, usually it'll be a directory associated with that at home. So now let's go to cd. So we know that this is the convention, like the command we need to change directory cd, right? So now like sorry, cd home / we have 19, right? So now we are at home. So as you can see, you might have guessed already, so this symbol is used to denote home. So when I do cd randomly, it gets me to home. So if I go to cd root, cd root, and then if I do cd, it gets me to home. So cd by default always takes you to home, right? And cd followed by / leads you to root, right? Cool. So if like let's say you go to like dot files or something like that. So go here, here. Now let's say I want to go back to home. I can do this, and I'm back home, right? And yeah, or like let's say I go to root / I don't know, right? So I'm here, and now let's say I want to go to dot files. I can do this by saying that right. So the / is nothing but what you use to denote like the file structure and stuff like that. So like I mean I wouldn't say use to denote file structure, but rather like it is the notation, notation that is used in Linux, right? So if you have ls, let's do ls here. Now let's, okay, there's something called src. Now let's, so the more deeper you go into a directory, like each level that you go into the directory, it's going to be followed with a forward slash. If you use Windows, if you might have noticed, it's a backward slash. So that is one major difference between Linux and Windows, right? Cool. So now we're back in the home directory. Okay. All right. So I'll take a pause for a minute. Is there any questions at this point? Is there any questions? Okay. Okay. Cool. I don't think there is any. All right. So now, couple of more things, like the way you can navigate around is you can use the up arrow key to like go through the commands, and like down, so that you can browse through the commands that you have entered or like given to the shell, right? And the way it works is like bash, the program that we're currently using, stores whatever we type into it in a particular file, right? Almost everything is a file in the Linux, right? So yeah, and we can use like tab for completion. So let's say cd. Now I want to go into a directory inside dot files, right? Dot files. Now if I hit tab, right? If I hit tab, it says that okay, there is .git, there is docs, there is lib, there is src. Now if I say lib, now it automatically completes it, right? Or if I say, and now if I hit tab again, I don't know what is there inside that. Okay, so there's nothing more I can go into, like it stops there, right? So there is tab completion, right? Cool. There is reverse search, right? For example, I think it's Control R. Yeah, Control R. And if you want to go through the history, like there is a particular command you don't remember, right? But you did use it like some 10 minutes ago, 40 minutes ago. So you can type ls, and then okay, ls is the last thing that we use, so it says ls. But instead, like let's say something, we use who am I? So yeah, and there is also this, if you want to reuse the very last command that you gave. So it executes the very last command that you gave. And there is something called dot bash history. So if you see here, you might see dot bash history. So it stores all the commands that you given. So we do cat dot bash. It stores the history of the commands that you gave, and you can, and that is what it uses internally to do a reverse search or to go up and down, right? And there is also clear command if you want to clear your screen. Now we have cleared the screen, right? Cool. And for pasting on your terminal or your shell, you can use Control-Shift-V, but this also depends on your terminal. Your terminal might, or terminal emulator, it might also support like using Control-V. Like for example, my terminal emulator, which is Windows terminal, it allows me to like do Control-V to paste. Right. Cool. We spoke that almost everything and anything is a file in Linux, which means that we should be editing them quite frequently, right? So text editors and file editors are of immense importance in Linux, right? So chances are if you install any sort of Linux distribution, you might get Nano, which is like a very, very, very small text editor. So this is GNU Nano, so it's basically a GNU software, right? And it says the version. So here you can type stuff. This is Nano, and you can see these things here, right? Options here, right? So this I don't know what this character is called, but this character is usually used to represent control, right? So this essentially stands for Control O. So write out is nothing but same. So if I say Control O, then I can say the file name. Like random file dot txt, right? And it says you can use Control X to exit. So I exit, right? So now, so it's a very simple editor, and it's very simple to get started with and getting used to. And now, if we look at our current directory, we've created this random file dot txt, right? Let's just leave because we don't need it. Right, I use tab completion. So again, you can go to nano and do Control C, and yeah, you will get all these help, stuff that you can do. But it's quite easy to get started off with, and it's pretty primitive. Yeah, and you can use Control X to exit. Cool. So if you want more complicated things, there's more complicated editors out there like Vim and stuff, right? Like this VI. I don't know. I think I might have linked VI to Vim here. Like Vim is a very cool model editor. It's like not something that I recommend you to get started with because it's a learning curve on its own. But yeah, like this is something that people usually use, right? So now let's go into some essential commands like well, let's speak about files in itself. All right, so let's look at less. It says missing file name. Let's look at the head. Essentially, less is used to like display a particular file, and it's a very fancy command, fancy program rather. Like it comes in with a lot of things that you can do. Like it has search, it has pattern search, it has jumping to lines and stuff like that, right? And you can use Q to exit from it. Cool. So let's look at a file. Okay, let's go to dot files. So dot files is this particular thing that I use so that I have a consistent system. Like wherever I go, I copy this dot files thing, and then I can set up my system to the way I want. So let's go to dot files. Right. So there's something called readme.md. So I think this is somebody else's dot files, but yeah. Yeah, sorry, I did that again. Now let's do less. Right. Okay, this is HTML. It's my idea, but you can do search. Right, you can give a / and you can say a line, and you hit enter. It search for a line, right? And I can hit Q to exit from it, and I can also do like, you can also go back up and forth, like, small n to go down, capital N to go up, and stuff like that. There's a lot of things you can do with less. There's a very cool editor, right? Use Q to exit it, right? There's also an like there is a opposite, like, I don't know, thing to it called more, which is, I mean, the thing is, the names are ironic because more is very simple, right? You can essentially do like go up and down. Like you hit enter to go up and stuff like that. More is very basic, right? And it's like nothing but a fancy cat. Like, yeah. Give me a second. Yep. So, yeah. But less is, on the other hand, very like feature rich and stuff like that. More is rather feature incomplete, I'd say. Just give me one moment. Cool. Sorry, something came up. Yeah. Now let's look at this command called man. So man stands for manual, right? So yeah, it asks what manual page you want. So you can do man is basically a manual for the manual, right? So you can use man with almost any command that you want, right? So, and to exit from anything, you can usually use :Q, and that should exit. So if this, if by any chance you open Vim or something like that, remember the way to exit: : Q, right? Colon Q, like you might sometimes by mistake get into Vim or by mistake get into something like this, and you might find it difficult to exit. Remember, colon Q is usually a way to exit from these sort of editors, right? So like, let's do man less. So it gives a manual for less. Less is opposite of more, right? Uh, yeah, and you can go up and down using your arrow keys, and you can also use HJK. So people might be familiar. Those who game, WASD is used as the replacement for up arrow keys. Similarly, in programming, a lot of people use HJKL to move around. There are some reasons for it, which I'm not getting into, but you can move around using HJKL, right? So we have to exit. Sorry. Yep. Cool. Then there is something called cat, which basically stands for concatenate, but it can also display a file, right? So it's displaying that file, right? So cat can do that, but it can also take like one file, another file, and concatenate. That's why it says cat. And then there is stuff like head and tail, like head prints. I don't know what the default of head is. Okay, I don't know what the default behavior of head is, but like what you can do is take head, and then you can say like, and it displays the very first 10 lines. I can also say that, hey, I want you to display like, 5 lines. So this is a flag, and then I'm giving a parameter to that flag. So it displays only 5 lines. So if I want to display like 10 lines, I can say like 10. Or 10 is a default if I'm not wrong. I want to say 100 lines, it can display 100 lines. Or how much ever it can go to. And there is tail, which is as you might have guessed, the opposite of head. It starts from the last, like, and it is useless. It displays the last 5 lines, right? Cool. So this is with regard to interacting with files and editing files and viewing files. Now let's look at how to create a file, right? Touch is used to create a file. Touch here, ls. Now we see here, right? So touch is used to create an empty file, right? Now let's do cat here. There's nothing in it. It didn't display anything because it's empty, right? Let's do less here. There's nothing in here. So I say, okay, here, there's nothing in it, right? So touch is used to create an empty file with a particular file name, right? And there is a fancy, like, you can also create directories using mkdir, which stands for make directory, right? Here. It's just it cannot create here because that particular file exists. So mkdir is nothing but a fancy way of saying that, okay, create a file and then change that the thing that we saw there, right? And make that a directory, right? So I don't know if this would work. I'm just trying it out. So that's an invalid option. I'll just remove here for now. And yeah. So now, if you look at this, it says here also a directory. So like you can create a directory like this, right? Now you might have seen it with RM. RM stands for remove. So we're removing a particular thing, like remove here. It says that you can't do that because RM, is a directory. So for that, there is a RM dir, right? RM dir here. So yeah. And with RM, you might have very useful flags such as R, which basically stands for cursor. Like, let's say I don't want to delete this particular thing, but like, okay, let's do this. Let's create a directory called here, get it here, and then let's go into here, and then let's create a random file called a1.txt and a2.txt, and this is very easy to do. I'm just doing it the naive way for now, right? So now if you do this, there are 3 files, right? Cool. And now let's say I want to remove the entire directory. I go back, I want to remove entire here, right? I don't want here. So if I do rmdir here, it's going to say that, hey, I cannot remove this directory because this directory is not empty. So one way to do this is basically go into here and delete every single file one by one by one. Or you can use a recursive flag and delete it, right? After do this, here is gone. So R stands for recursive, which basically says that it will delete every single content regardless of whether it's a file or a directory. You can also accompany it with the F flag, like RM, RF, and that forces it to delete if there is something going on, or there's some process using it or something. It just forces it to delete or remove rather. Right? Okay. Cool. Now let's just do that whole process once again, or let's use reverse set. Right? We create a directory. Now let's touch. Right? Oh crap. Yeah, it's actually pretty good. So now let's look at this. There is here, and then there is here1.txt, right? Now let's say I want to move here1.txt to here, copy paste. There's a very good command for it. CP stands for copy, right? You can say what you want to copy. This is basically here1.txt, and I want to copy it to here, right? So I just give this an ls. Let's look at let's do an ls here, right? You can see hey1.txt has come there. Note that this is copy and not cut, so there will be the initial copy there. But if you're interested in moving something, there's a command called mp, which stands for move, which basically says that move. Hey. Yeah. Now if I go to ls here, there is nothing, and if I do an ls here, there is no hey1.txt because hey has been moved to this particular directory, right? Cool. So I think we've worked through the basic things. So make sure you remember these things: mv, cp, less, more, cat, and they're going to be very useful, right? Now it also comes with wildcards, right? So okay, let's do this thing once again. We are in here right now. No, let's go to here. And let's go to we have here1.txt, right? And now let's also create things like here2.txt and stuff like that. Touch here2.txt. Right, now we have these three things. And now I can say rm hey I'll explain that. As you can see, everything has been deleted, right? So what's happening here is this particular thing stands for a wildcard character, right? So what this does is it replaces this thing with anything that is available. It will delete everything. This particular character can be matched with any other character, right? And it might match no character also. Even if I do touch and run this command again, it has moved up. So basically this particular thing stands for 0 or 1 character, and then 1 character can be any character. For example, it needn't be 1, 2 or 3. It can be anything. Let's do touch a.txt, and now let's do this, and now let's do this, and see, it's gone. So it can stand for 0 or 1 character, right? And if you don't want to do 0 and it's exclusive to only any character, then there is something you can use the question mark character. So let's create touch. Right now, if I use this one, it will delete this particular file. But if I use this, it says that no such file or directory exists, right? Can anybody answer why? I really like this session to be as interactive as possible, which is why I'm trying to ask questions. Okay. Yeah, it's because the question mark means that there is at least 1 character, right? It stands for any character, but it can't be no characters. So if I do this, it'll work because underscore is also a valid any character, right? Now if I do ls, it's not there. So that's the difference between like the star wild card and the question mark wild card, right? Okay. So and if you want to limit it to something, you can use something like this syntax. This is to. Alright. Before that, I'll show something else. We look at expansions so that our job gets easier. So like you might have seen that we had to create like hey1, hey2, hey3 or txt, and it's kind of cumbersome. So we can do something easy. We can do like touch. Um, no. Right. Excuse me. So now we might like using this one single command. I created 3 files. What it essentially does is it expands this thing into 3 different things and uses the touch command on top of it. You can use expansions wherever you want, right? It's not restricted to files, but as long as it's string, it should work just fine. And there's one more thing in Bash. Almost anything and everything is like a string variable, right? Like yeah, and cool. So, and if you want, you can use like anything else, like A, B, or like hello, right? So it's kind of as simple as this. And if you want, like you can also like iterate through stuff like numbers. Or wait, let's look at something more complicated. Right, so it has generated all these files from this expansion set. This is a pretty cool thing, right? You might not use this quite often, but if you want to do something like this, it's quite quick, right? And I think there's also you can also do that with alphabets and stuff. Let's try it out. Yeah, so it is. I mean, down that like it is created with alphabets as well, right? Cool. And I think there's some way to do like steps and stuff like that. Anyways, so like now let's say I want to remove the file which contains a number in them and the number from 1 to 5, then I can do so by like saying rn a and use this particular square bracket syntax to be like 1 to where did we go? 20, right? 20.txt. Do an ls now. No, wait. I don't know why this isn't working, but there's something like this. I'll get back to this tomorrow, I guess. But this should have worked. I don't know why the range expand. I mean, why limiting characters are not working. Oh, okay, I think it has got something to do with it's like 3 to 5. Okay. So I think it has got something to do with the 20 thing, double digits. So I'll look into that and get back. But yeah, it's pretty cool and you can use wildcards and replacements. And if I just want to delete the whole thing, I could just go back and like rn or what is the name? And that whole thing is deleted. Cool. All right. Any questions at this point? feel free, feel free to ask questions or interrupt me at any point. Okay. Now let's look at streams. Okay. So we might have initially, I might have said that input and output, like the whole Unix philosophy has got to do something with input and output. So like you take input from something and then you pipe it to the output of, you take the output of something, you pipe it to the input of another thing. So that's usually done via the means of using streams. So like, let's say you're printing out something. Okay, let's create a file called, let's move into a new folder. Let's create learn bash. So, right. Now let's cool, and let's create a file called file1, right? So we do touch file 1.txt. Now let's look at there's nothing in it. Okay, so also there's one more command I forgot, which is echo. So echo basically means what it says. It's like echo out whatever you, so like you do echo, you do echo here, it prints out here. So echo is just like echo in the mountains. When you say something, it repeats the same thing back to you. So it's exactly what that command does too. Right, so you do like echo random things, it prints out random things. Right? So the thing is, this particular output that you see is nothing but the standard output that's being printed, right? So if you let's do something like this, right? Echo, I'll explain this in a bit. Echo random things, and then let's do this. What is that? File1, right? So now let's do cat. Okay, cool. I typed run form things, whatever. So let's look at what happened here. So what this essentially does is that it does, let's look, think about the record, right? Read, eval, print, loop. So I read this whole line, right? And then what did it do? It's like it realizes echo. So it evaluates this expression, echo ran form things. So echo is basically the same thing, right? There's no difference. Now so echo prints stuff to the standard output, right? So now something is printed to the standard output. Now before our bash gets to print the thing from standard output, we are saying that redirect everything from, so this one forward angular bracket stands for streaming everything from the standard output to this particular file, right? And then what happens is that by the time this gets executed, there's nothing left in the standard output. The standard output gets empty, right? So yeah, so there's nothing to print. So let's look at this whole thing again. You type this thing, and first what it does is it performs echo. So echo takes this particular string, and then it prints that particular string into the standard output stream. And then next thing that happens is this particular thing, one stands for std out, standard output, right? And it streams it. This is used to stream it out, right? It's basically like redirecting it outside. And I'm saying that redirect to a file called file1.txt. It could be some other file, right? But the thing is, this overwrites, and if you want to append rather, you can use this. Let's look at so it is appended, but if I do this, it has overwritten. So like you can use this to append a file, and you can use this to overwrite a particular file. And you can use this the other way also, like to get input also. But yeah, and if you want to like print errors, then there is something called stdl. So, but there is no error in this, so it won't add anything there. But yeah, you can do that also. And usually what happens is that there's something called dev null, which is where you put every random thing in, like ls dev null. There's nothing there yet, but that's usually where you put your temporary things and stuff like that. And there's also std in, which if you want you can use like cat. You see the direction is reversed, right? Wait, why is that not bad? There's nothing in file because yeah, okay, we emptied it. Let's do this. Now let's look at file. Okay. Now it's pretty much the same thing, but the thing is, what the difference is that here it takes the file and just prints it as the output. But here it takes that file and redirects it to cat. So cat can not only take file as an argument, it can also take input and then print that as the output. Right? That's the only difference. Yeah. Now let's look at pipes. Pipes is pretty cool because it allows you to connect things together, and that's like one of the coolest things I feel in Linux is. So like, okay, let's look at this command called grep, which I think stands for global regular expression. I'm not quite sure. Let's. It stands for, one second, I'm just checking it out. It stands for global regular expression print. Cool. All right. Alright. So that has got something to do with the regular expression, which you needn't worry about at this point. But basically, you can say that you can search stuff with it. So if I do like I can like search for a particular keyword and something, right? So now what I'm doing is I'm taking like this thing, like file, right? File1.txt, and now I am grepping there. So I'm searching for ram fun, and let's see what happens. Where it highlighted ram fun, right? Because it got a selection. So what's essentially happening here is that it's doing this, and then the output of cat, like what is cat 51.txt here? It gives this, right? And this output, the std out, is piped to the std in of this, right? So now let's look at grep. Okay. So grep, basically grep option pattern and file. So grep, what is the pattern that you want? Pattern is the thing that you're searching for, right? So ranform is a pattern, and now file is optional, but file1.txt. It's the same thing, right? The only difference here is that I am taking the output of cat, which is nothing but which is nothing but essentially file1.txt, and giving that as the input. It's very useful in doing really complicated commands and stuff. Like, you take the input, like for example, you want to install something, and then you're using like a script, right? It downloads a bash script. So you can just pipe it to bash, and then instead of even without even writing the file onto your system, you can run that thing. So yeah, that's pipes. And next we're gonna go to users. Before that, I'd really like to take a pause and understand like what's happening and stuff. Like if you've got any understanding of this, do you have any confusion, do you have any doubts and stuff. It'd be really great if somebody can talk at this point so that I can get some feedback. It'd be really great if you could give some sort of feedback as to how how things have been moving on and stuff like that. Okay. Any doubts? Anything? Cool. All right. Okay. Cat. Okay. So let's look at cat. So, okay, it's something to do with the code details. But what it does is it concatenate files to standard output. Right? So let's do. Now we have file1.txt. Now let's add something. Let's say random things, and let's like put it at file2.txt. Now let's do cat. All right. So what cat can do is, what cat actually does is it concatenates things. Concatenate means join two things. So do cat file one. Right. So what it does is it concatenates these two things and prints that to the standard output. Now, has that affected the files themselves? Let's see. Oh, sorry. Right. So the files themselves have not been affected, but you can concatenate two files and print that to the standard output. Now you can also like write it to a new file and like or rewrite a file. That's a different thing. But essentially, it stands for concatenation. But the thing about Linux is that it's very composable. The commands are usually very composable. And like if you don't have two files, if you only have one file, it'll just print that thing to the standard output. So it takes a particular file, and if you have more files, it concatenates them, and it I mean concatenates is not a fancy word, join, and then prints that to the standard output. Right. Hope that's clear.
Okay, so I think it's really time to wind up. It's 8. So
Okay.
we'll resume from tomorrow. So thank you, Varun, for such a very informative and very, very efficacious session. It was really, really worth listening to. And also thank you to all the students who showed a keen interest to attend the session. So kindly join tomorrow's session using the same link, but timing is same as today. So let's wind up today's session, and don't forget to join tomorrow as it is going to be more interesting the next day. So thank you all and good night.
Right. Thank you. Good night. Anyone have any questions regarding the previous session? Ideally, I wish to conduct both the sessions like on consecutive days, but due to some unforeseen circumstances, I couldn't. I mean, it didn't go the way I expected it to go. So yeah, did anyone try it out or like have any issues? And I hope everyone has way to access Linux CLI or like a bash shell currently. Any issues, any questions, anything? Okay, so I think we could probably start off, like we'll just go through a rough sort of recap. So we saw what Linux is, we saw why learning Linux CLI can go a long way. It's an operating system, it's a free and open source operating system, and it's very easy to understand. Very easy as in it is very easy to access. If you'd like to know how something works, you can always go to the source code and check out how something works. Figuring out how it works is a different story altogether. It's a very developer friendly operating system. You can customize it however you want. We also went through how Linux could be installed. I'll be sending a blog post about that, which you could all access. Then we saw what a shell means. Shell is like a programming language, a language we can interactively program in. It's essentially a REPL, a read eval print loop. I hope I'm audible.
Yeah, you're audible.
Right. So it's a read eval print loop. There is like input, there is an output for most of the functions, and essentially whatever command you give, it reads it, it evaluates that particular command, and then the output gets printed, and this thing is repeated until like it's looped on. Right? So it's a very interactive way of programming, unlike let's say like C or C++, which is like a compiled language. Right? Um, it's a very lightweight programming language, you could say. I mean, a lot of people prefer not to call it a programming language, and I think it doesn't make sense to call it a programming language in the way we look at programming languages. But at the end of the day, it's like a very interactive way of programming. So we spoke about Bash, which is the shell that gets shipped along with Linux by default. There are also other shells like ZSH, and ZSH is the default shell that comes with macOS, if I'm not wrong. There are also other shells like C shell and stuff like that, which has a very C-like syntax and has type system. Bash is very interactive, very uh, there is very little friction. There is no type system whatsoever, and it's uh, very easy to interact with. We also saw how file system is the core of Linux, right? Like everything, I may have said that almost anything and everything in Linux is a file. So whatever is there in Linux is essentially file. Also, I forgot to mention, like, um, I think I also spoke about how Linux is just the kernel, and essentially when you use Linux, or what we call as Linux is nothing but GNU/Linux, and not just Linux. Linux is just the kernel. We use a lot of GNU utilities along with Linux for us to make use of the system properly. And we spoke about the home directory. Like this is a symbol that's used to like denote the home directory of that particular user you're logged in with. This is used to denote the root directory, right? We also saw like help command, and we saw how to navigate using ls. We saw how to change directory, pwd, print current directory, and so on. We also spoke a little about flags, how like if flags is a way of manipulating a way of program or command work. So ls is a program, I mean ls is a command, but at the end of the day ls is also a program, right? The command. So you can give l and it would list all the files along with its file permissions and stuff like that. And I think I also illustrated how lsa is used to denote like hidden files and stuff like that, right? There's also something called a hedge. There's also something called hedge. This is basically human readable format. So like, I think if you do this, yeah, it like here it says like 4096 and stuff like that, which is fine to read, but 4 kilobytes is easier to read. So hedge I think is used for a human readable format, something of that sort, right? Yeah, we spoke about tilde, we spoke about slash, we spoke about how you can go up through the command down traverse like this using the up arrow key and down arrow key. There's tab completion. Tab completion differs from shell to shell. I feel that ZSH offers a lot of ZSH offers much better productivity in comparison to Bash. Also, I think I'm currently running ZSH. Let me just go to Bash. Yeah, I'm in Bash now. Cool. We spoke about reverse search using Control R, right? So yeah, and we spoke about Bash history also. Okay. Yeah, so like we spoke about Bash history, right? Like it stores all the history of all the commands that we have run, and we spoke about which is it prints the last command that we ran, and we spoke about clear, which is used to clear your your uh, uh, like it clears the output, and yeah, that's I think we briefly spoke about control. I didn't want to go into it, like, but yeah, and we spoke about like how everything is a file and hence the need to edit stuff. So I think we should have spoken about nano, right? And like how you can write stuff here, and you can just save it via Control O and give some name, and Control X to exit and stuff, right? Now you can delete it using TJ, right? Yeah. So nano is a good rather than good, very easy way to edit. Not easy, very simple. It's very simple, and also the barrier to entry to like using nano is very little. And I think I might have briefly mentioned Vim, but I didn't want to go into Vim for obvious reasons. But like there is Vim, it is a modal text editor. If anybody is interested in like using a terminal-based text editor or like a non-graphical text editor, Vim is a really good place to start. There is a learning curve associated with it though. However, I might have mentioned how :Q is used to exit, and there you might encounter places where you might enter a Vim, like where you might enter Vim by mistake and you might have to exit. And the way to exit is :Q, right? So we also spoke about less. We spoke about more. We spoke about cat. We spoke about man. We spoke about head tail. Can anybody maybe tell what less is for, more is for, cat is for? I don't mind going through it once again, but if anybody could do that, then I think that would be more interactive, like Bash maybe. Anyone, like, just say whatever you have in your head about less or more or cat. Okay. Um, just say whatever you have. Like, it doesn't matter whether it's wrong or right. Um, like, only if it's wrong, there is, I mean, it can be corrected, right? So there's nothing wrong in saying something wrong. Okay. Nobody saying. All right. Cool. I think I'll go over them by myself. So less is like to like interact with the files, right? It is it's more about reading files and stuff, but like it's not as feature rich as like Vim or Nano when it comes to editing files, but it's like useful, you know, to like search. I think we went through. Okay, let's take a file. Nothing here. Let's go to like dot files. Okay, cd. Let's see what's here. Let's create here.txt. Touch here.txt. Now let's open it in Nano. Right. Okay, this is a simple file. Now let's save it. Now let's exit. Right. Now if we do less, a, so we got this, and it has like sorry, it has got like search thing, this thing, right? So you can search even in a more complicated file, I think, and the way you in a more complicated file you can do more complicated things, like you can use, I think, small n to go to the next occurrence of a match and capital N for a previous match and stuff. So less is actually opposite of more, and I think I showed this too. More is the simpler version of less, right? It doesn't even go into like its own new output, right? Cat is basically a program to concatenate stuff. It joins two things together, but if you give just one thing, it just prints that thing out, right? And we spoke about head and tail also. It prints the first n lines. The default n is 10. You can modify it using the flag. Tail does the last n lines. We spoke about mkdir, creating a directory, rm removing a file, cp is copy, mv is move. I don't think we spoke about tar, but that's fine. Cool. We spoke about wildcards, right? We spoke about how if you have something like touch A1, A2. Now if you do R, let's see if it was created. Yeah, we have A1, A2, right? Now if we have like uh, RM, A star, and let's look at what's there now. A1 and A2 gets deleted because star is basically a wildcard operator. So this is more to do with something called as regular expressions. So wildcard operators are used in regular expressions, and I think we also went into expansions and stuff. Like how we can do like touch together, file, right? I think we also went through ranges, right? Like how to create ranges using expansions like 0. I think it's taking some time to do it. Yeah, so now, sorry. So there's like 100 files created. Now RM file. Yeah, so I deleted all the files, right? And the same thing can be done for alphabets. I think where we stopped were streams and pipes. We spoke about how std out, std dir, and pipes, like how you could take the input of one program and pipe it, like sorry, you could take the output of one program and pipe it to the input of another program, right? That's where we stopped. I think that's where we stopped, correct? Any feedback? Any questions, any clarifications, any doubts, anything? All right. I hope in that case I could probably proceed. Cool. So the next thing that I'd like to cover is the concept of users. So I think I started with this, but it had to. I mean, we had to wrap the session due to like the limitation of time, right? So, uh, so Linux is inspired from Unix, and the reason why, like, one of the inspiration motivation for creation of Unix was like a multi-user system, and a multi-user system which can be controlled and administered and managed with ease. That was one of the motivations back then. And back then, there was a very different view of computers. The way we view computers today was not the way computers were viewed back then. Unix was, if I'm not wrong, was created in the 70s, and back then the concept was that of mainframes, right? Like you had a really large system which could occupy the size of rooms, and they'd do really complicated computations and stuff like that, and you timeshare the resource. Like you have like you have the computate, like the resource, and then you share that particular resource across a set of people or departments, something of that sort. Having one's own computer was not even a luxury, it was more like impossible at that point of time. So users was more of a requirement back then. Like a concept of users was very much required, and every user, like ideally every user should be sufficiently isolated from another user, right? So even if you use Windows or any modern operating system, there is a concept of users. But I'd say that Linux, uh, Linux or GNU Linux, gives you more ability to tamper around with stuff and like move things around. When you use things like Windows and macOS, you're restricted um, because essentially you can't go and change stuff internally, like, right? Yeah. So right now, if you look at the prompt, so I think I might not have mentioned prompt. Prompt is basically this thing that you see, like it says that VHawk 19, it's desktop 1SI something something, right? And dot file. So this whole thing is basically the prompt. It is it's prompting me to give an input, right? It's prompting me to give something, so it's called a prompt. You can customize your prompt But let's look at the prompt for a minute, and let's look at what it says. It says that vhawk19 at some desktop something, and this is the current uh, file of directory I'm in, right? We also discussed how every directory is also nothing but a special file, right? Yeah. So this is your user and this is your system. So if I do who am I, it's a command to see what is the current user you're logged in with. So it says vhawk19. So this is the username I have logged in with, right? So to see, if you want to see the list of users, you could go to etc password. It's not password, it's passwd. Uh, so it says like a list of like users. So there might be system generated users also. Like for example, you might see something called like uh, I don't know, MongoDB, Postgres. So these are created by a particular program. So it created a user, right? Let's just try creating a user now. Let's add what name would should we add? Any suggestions? Okay, let's just add some like random user. Okay, let's call it new user, right? So let's do user add new user. It says permission denied. So I think I don't know if we spoke briefly about sudo, but sudo is basically the way of almost doing whatever you want to do. So it basically stands for su and do. Su stands for super user and do is basically do something. So what it does is it gives administrator privileges to do whatever. So it's like in Windows you have like run as administrator, in Linux you have sudo. And usually if something doesn't work and says that permission denied, sudo is a good way to like probably rectify your problem. There might be other reasons why it doesn't work, but sudo works. Like sudo might resolve that issue, right? So let's do sudo user add new user. Okay, it's asking for my password. Okay, so has it created new user? Let's see, cat etc. See, so it has created new user. Forget all this. This is basically like the things like what is the uh, this is basically the starting directory. If you log into this particular user from some shell, it says it goes to this directory. Like if you go for this is the home directory, right? And this is basically telling what is the login shell. So for example, I use zsh. So if you look at my, can you see my cursor by the way, or am I just pointing at blank?
Yes, it's visible.
Okay, so yeah, so if you look at my username, it says a login shell is zsh, and this is like my home directory, right? So similarly, I just created a new. The default shell, as I said, for all Linux, most of the Linux system is Bash, so it says bin/sh, right? No, this is actually shell. Like sh, Bash is born again shell. I'm it's like I'm not sure of the differences, but yeah. There are also like other things like Pulse Audio, Awahi, and stuff. These are the things used to manage like audio and stuff like that. It's created by that particular program. It's a auto-generated user. You have not created it, right? Like MongoDB, Postgres. These are databases. Pulse Audio and like Awahi and all is used for like audio. And Genome Display Manager. That's one more interesting thing to note about Linux is the way it views everything. At the end of the day, anything and everything is like goes through like files, users, sockets. Like it's kind of like Unix sockets, and that's how almost everything works. Like in Windows, everything is based on like the Win32 API. You have to create like a service. It has it's a very structured way, right? But in Linux, it's more like you have these things and you build these things along with it. So like the concept of daemons and stuff like that, it's very different from that of like other operating systems. Daemon is basically a program that keeps running continuously and it doesn't stop. So that's what like you might see like USB mux daemon and stuff like that. It constantly runs. So that's what daemon stands for. Right. So yeah, we spoke about sudo, and let's now add a password for the new user. So this is way of adding password, right? So password and new user. So it's asking for password. Let's say new user. New user. Okay, I think I made a mistake. New user. New user. Cool. So now password is updated successfully, and now to like. So now I'm currently in like I've updated this thing appropriately. Another thing that I want to say is basically how you can go into root. So a root user comes along with I'm not sure, but almost all the distributions is a root user that comes along with it. So if you do like sudo su, then it takes you to root, right? So so when you enter sudo su, like you're accessing a system with a root user privilege. Like any command that you do within this is now with root user privilege. So it's you should not use it unnecessarily, and this is a nice way Linux uses to protect itself, right? Using privileges and permissions and stuff like that. Linux permissions is very different from like Windows permissions and stuff like that, and it's easier, but also a good way to like unless you give a program the privilege, it cannot run a privileged thing. So it's just like run as administrator in Windows, but a lot of things require administrative privileges in Linux, right? So let me exit. So yeah, cool. Now that we have done users, let's look at something called groups, right? So what does anybody would anybody like to guess what a group means? Okay, cool. So, so groups is basically a way of abstracting a set of users. I might have mentioned earlier that you know when Unix was created, it was like a mainframe and stuff like that. So like departments and like a whole set of users might use something, right? So there might be a need to like for example, like let's say MEC. Now let's say the entire MEC is in like model engineering college, right? So like let's say we have MEC and like we have different departments. So we have computer science department, electronics department, electrical department, biomedical department. Now even though like let's say every faculty, I mean each faculty gets his or her own system and like user account in a particular server, it also makes sense to like group all these particular departments based on their department names, right? So for example, electronics department does not need access to the marks of like or marks or like grading or like remarks of computer science department, right? So groups is basically a way of saying, hey, with these bunch of users you can do like it's basically you're categorizing a bunch of users into a collection and you're giving them a name. So that is what groups is. And just like how you can set permissions for a file, like for user, you can also set permissions for a group, right? So let's maybe look at groups for a second. Right. So let's first look at, and there are also like different things. Like I'm not quite sure about this. There's like primary login groups, and there's also like secondary groups, stuff like that. Anyways, I'm not quite sure if it's distinction, but yeah. So let's look at groups for a second. So when I do groups, it says that there is like like these are the groups, like VHOC 19, ADM, dial out, CD-ROM, floppy, sudo. So even sudo in itself is a group, right? And like sudo is, I mean, I mentioned that sudo is like super user do, right? And audio is a group. So audio will have everything related to do with audio. Like it might have like pulse audio, it might have like Avahi and stuff like that. So, and like, I don't know, CD-ROM and floppy is largely irrelevant now, I feel, because they're mostly non-existent. But again, this was created in the 90s, so you must take that into account as well. And like, to list all members of the group, there's this thing called get int of group. Now, sorry. So you can give the group name. So like we have 19. So it says, acha, so this is the users in this particular group. Now, if I say sudo, it says that there's only VHOC 19 there. So because I'm the only root user of this particular like instance of operating system, like it says there's only one user. So now let's try something else maybe. Let's try audio. There's only pulse audio. So pulse audio is like grouped into something, right? And I don't know what, I have never tried this out. Let's just try it out maybe. Yeah, I don't know what that means also, by the way. But yeah, so you can list everything in a particular group, right? You can also do all these things usually are present in like EDCs. So if you want, you can go and check. So this is like every single thing, all the groups, right? Yeah, without being grouped appropriately. Yeah, so is everyone clear on what groups is? Okay, I hope everybody's clear. Any sort of feedback, any sort of doubts, clarifications, do put it up so that I could possibly help you out in a better way. Cool. Now let's go to permissions. So you might, okay, let's do ls l, right? So now you can see over here, there's like this thing. I think I briefly spoke about this, like if you have D, then it's a directory and stuff like that. So let's just try to like understand this particular thing, right? So this thing is used to denote the permissions. Okay, so the very first character in this denotes whether this given file is, whether this particular file is a directory or not. So if it is D, then it is a directory. And I'll just tell what R, W, and X means. R stands for read, W stands for write, and X stands for like execute. So before we move ahead, let's like split them into like three sections. So you can imagine D, let's type it out. D. Let's look at docs, right? Let's just split this into like, right. So it's an easier way to like visualize this, right? So the very first column, or like the very first three characters after the first character, stands for user permissions. So RWX is basically read, write, execute, right? So this means that the user has the ability to read that particular file, the user has the ability to write to that particular file, and the user has the ability to execute the particular file. So execute basically stands for, like, let's say you have a program, right? Let's say you have a Python program, or let's say you have like a Bash program, or any program for that matter. You can take that and you can execute it, or rather, like it makes more sense in terms of like like you compile down a C program or a C++ program, you have like an output file and then you run that. So you can't run it if it's like this. Then you can't run it. You can only read it and write it. You can't execute it, right? The next one stands for group. So anyone belong. So when I say user, I mean the user who is currently logged in, right? The current user, like whatever is the output of who am I, right? That user has the ability to read, write, and execute. Anyone else does not have. I mean, we'll come to anyone else in a minute, but RW, the very first RWX, so the very first three characters after the first character. The first character is basically whether it's a directory or not. That's it. The next three characters after that talk about user permission. That is the permission levels for the user currently logged in. The next three characters talk about the group to which the currently logged in user belongs to. So like, let's say that we're talking about like in college, like MEC, and the way that they have made their users is in such a way that they've grouped according to departments. Now let's say like there is a particular faculty who is logged in, and so that particular faculty has all the access. So the particular department that the faculty belongs to, however, has only read and execute access. They cannot write. And anybody else, right? Anybody else, regardless of what department they are and stuff, they have only read and execute access. They do not have write access, right? And it differs for each file. It all depends on these three things. There is a mnemonic which I'll be coming to, like a sort of shortcut to represent these things using by converting, like there's some number system, not a number system, but like way to represent. I'll come into that in a bit. But basically there's this thing called chown, which is basically change owner, which is used to change the ownership of a particular thing. So like we created a user called new user, right? So if you want, let's do one thing. Let's create a directory. Let's call it hey, right? So now let's do ls. So now there's hey, right? Now let's do okay. All right. Now let's just do this. Okay, so hey has the same thing as all the others. It has write, read, and execute permission for the user, and only read and execute permission for all the other users. Now let's try changing the owner. I think chown requires sudo, so you might have to add that, because I mean not sudo, it requires privileged user. So when you do sudo, it's essentially telling that hey, you're giving privilege to this particular command, right? So yeah, I mean you're running that particular thing as in root user. So yeah, so sudo chown. Right, so now let's give it to, I don't think there is, yeah. Okay. All right. So now let's look at okay. So I think yeah. Now you can see that the user that it belongs to is new user. So these two things, right? So this basically represents the group this particular file belongs to, and this represents the user the file belongs to. So now let's do who am I. It says vhawk19. So I should not have write access to new, like hey. Now let's just go to hey. cd hey. Let's touch hey. I think this is happening because vhawk, it's like I'm a root user. I'm not sure about this, but I'll get back to this a little later. But essentially, and I think it has got something to do with directory. I'll get back to this in a while. I'm not quite sure of this. But yeah, so you can manage groups and you can sort of manage permissions using chmod. A more frequently used command, however, is chmod. So chmod is basically a way of like changing a particular like permission level, and it's a command you will see quite often because you do not want unnecessary permissions on a particular file, and because of which a lot of files come with restricted levels of permission. And like you might go to like Stack Overflow or something and they'll tell like, you know, it's you type like chmod 777 file name, it would automatically work, right? It might work, but it's a bad idea. So bad idea to add chmod 777 everywhere, because it's basically giving everyone the access to that particular file, right? So before that, let's just look at another thing. So imagine that R stands for 4, okay? Imagine R stands for 4 and 2 stands for right, and sorry, and execute stands for 1. So this is a way with Linux, this is a, like, I don't know, a naming or like a mapping technique Linux uses or whatever. Basically it's an association, right? So read stands for 4, write stands for 2, execute stands for 1. So if you if you look at like RWX here, right? So we know R stands for 4, so we take 4, W stands for 2, so 2, and X stands for 1, so 1, and then we sum these 3 bits. So 4 plus 2 plus 1, 7. So whenever you see 7, that means it has all the privileges: read, write, and execute. But if you take this, it will be R is 4, so 4. There is no write, so 0. And then there is execute, so 1. So 4 plus 1, 5. So this will be 5. And this will also be R, which is 4, 0 plus 1 to 5. So this can be represented as 755. It's basically a shortcut for representing this thing here. Similarly, like, let's look at this maybe. So R is 4 plus W is 2, and there is no execute, so it is 6. And there is only read here, so 2. There is only read here, so 2, 0, 0, 0, 0, so 2, 2. So it's 6, 2, 2. So in a lot of things, you might have to set the permission. So chmod can be used to like change the permission. So like, let's take here, right? So here is currently at what? RWX hence 7, RX hence 5, RX hence 5. So it's at 755, right? So now let's do chmod 622 on here, right? Now let's do ls, right? So yeah, sorry, my bad. So this one would be 644, not 622, because read is 4 and write is 2, right? So we have 622. So R plus W is 6, 4 plus 2, W is 2, W is 2. So hence 622. So now let's bring it back to like 755. Sorry. Oh my God. So now it has come back to its original thing. So this is a very, very useful thing, because like certain programs specifically ask for certain levels of permissions. If it exceeds that level of permission, if it's more accessible, then like, no, this is way too public. You please, restrict your permission. Or some might say that permission is denied. Please elevate permission. So accordingly, you can elevate. I'm not very aware of groups because I haven't used it to a great degree. So yeah, but this is very much required, especially in like, let's say you want to connect to an AWS instance. This is a very common way, common place where this is encountered. If you have there's a particular thing called there is like a PEM file or something. Don't need to worry about that. But that's a way you communicate to like connect to an EC2 instance. So that has to follow this particular permission. You have to set it to that permission. Without that, you can't even access it. So like chmod. So the thing, like, if you go to Stack Overflow, they'll like make it chmod 777. But it's usually a bad idea to like do that, like, because then it can be like it's possible that somebody has access to some other user and then can access your file. So that's a bad idea. Cool. Now let's look at environments. Okay, we're running short on time. Any feedback, any doubts at this point? Cool. All right. Okay. So environment. Environment is a very fundamental concept. It's not just restricted to programming, right? It's not just restricted to development. It's not just restricted to operating system. Environment is basically a very human and natural concept. So you might have heard statements or quotes like your environment dictates who you are and stuff like that. And that's largely true for programs as well. But the only difference is the way program views environments is just via environment variables. So environment variables are variables set in the environment, and you can access these variables from your particular program. So in like Bash, you like it's like capital letters, right? And like let's just do. I'll just explain after I do this. Yeah. So we just okay. Echo is I mean we spoke about echo, right? Echo basically stands for like it means echo, like return that same thing and print that same thing. So it says that hey, I am $user. So now let's do just $user. What should it give? It should give nothing because I didn't do an echo. So let's do this. It says vhawk19. So $user basically it's a variable that represents the current user, right? So I am currently vhawk19, hence it shows vhawk19. Now let's just do print env. As the name suggests, it prints the current list of environment variables. That's like a long list of things, right? Like it says shell is this, and it says there's something called user. So we saw user, right? Now let's do like this is what I did earlier, right? So what this does is dollar is like used to like signify or like tell that replace that value with whatever the environment variable is there, right? So there is a variable called user, and now I'm telling Bash to replace this particular thing with that user variable. So if I do this, it takes the value from user and it puts it here, and then it evaluates this particular thing. And you can do even more like complicated stuff. So for example, now let's make user equal to hey, right? Now if you do this, it says hey because it's just a variable, and then I just change the value of the variable. One important thing to note is so one important thing to note is Bash is very space sensitive, like space, like the thing on the keyboard, like space character sensitive. So like, or rather white space sensitive. So this is not equivalent to that. So when the equal to has to be without any space. Like, this would work. This would work, right? But that won't. So that's something to be noted. And the environment is temporary. Like, if you create, like let's just do one thing. Let's create a variable called variable. Now let's do print env. Do we have variable? Wait, yeah, I don't know. I couldn't see it here. It's probably if I do a grep on it, I could probably see it. Yeah, so that's one more thing that you could do. You could like take this output and then pipe it to grep and see the particular variable, but here we could have just like printed the variable. So now I'm not sure of this, but it should work. Can you see the screen?
Yes.
Cool. Let's do this. No, what is the name of the variable? Variable rate. Cool. There's nothing. So the thing is, when you add a variable, it's very similar to the way you view programming languages. Right? So let's say you take like a C program or like C++ program and you define a variable. What happens is that once you execute the program, or once rather like it goes out of bounds, it gets like, I don't know if it's more like this, probably garbage collection and all that, but like once it goes out of scope, it's no longer available. It can no longer be accessed. So similarly, the scope of a bash shell ka variable is limited to that session. So here I opened a new session and I did echo $variable. It was no longer accessible because it is limited to that session. However, if I want permanent variables, then you can update it in your bash RC or a bash like your profile. So there's something called, let's just go back to home and let's just look at this. Sorry. So you might see this thing called bash RC and yeah. So bash RC is where you can sort of add your, let's just look at yeah, so this is my bash RC. So it basically tells do this, do that and stuff, right? So it's yeah, so you can, so bash RC is run each time. So bash RC is basically, it's a file that gets run at the start. So if you add something here, each time you open a shell, the bash RC gets executed. So like if you add variable is equal to 2 here, every time you open a new shell, right, that particular thing is run. So variable is equal to 2 will exist. And there is also a way you can do it from etc, I think, and I think it's sorry, right, yeah, so there's this thing called environment, right? So let's just look at environment. So it has path variable and that's it. I'll get to path in a bit, but so this is a more permanent way of adding stuff. So if you add anything here, it adds to the Linux, like it adds to the environment, and it is independent of the shell. So if you're modifying your bash RC, if you're opening zsh shell, it may not come there. So bash RC is run each time you open a new bash shell, right? But etc environment is like, regardless of whichever shell you are, each time the system boots up, this particular variable would be loaded into the environment. Let's go home. Cool. Yeah. Now let's go to this thing called processes. I'm not going too much into processes because you'd need to have a good understanding of operating systems to understand processes and like all that stuff. But a very good way of viewing processes is like an independent thing, a thing that runs independently and consumes its own set of resources. So you can use PS to see like the list of don't focus on like TTY and stuff. It's basically tele typewriter, but it's basically tells which file name your terminal is connected to or something like that. But the more important thing is the PID and the command. CMD stands for command. So the PID stands for the process ID. So every single process in your operating system has a process ID associated with it, and it is associated with a particular command, right? So each time you run a command, so it has a process ID along with it. So now let's look at sleep. Sleep is basically a command to like make something wait for a particular amount of time. So like let's give sleep, and let's do sleep and then do PS. So now you have like one bash command along with it extra, and now let's look at PS once again. So yeah, the bash command is gone. So I think sleep should have been process ID 1077, but let's do sleep. Yeah, okay. I should have given it as different command. So yeah, so 1080 is the sleep command ka process ID. Now let's do PS. It's still there. Now, how to kill a particular process is very useful. Like for example, very useful. In fact, like let's say you're running like a database, or like let's say you're running a program, and like and it gets stuck or it gets hung up, and you don't know how to exit, then you can usually kill and stuff like that. Like you can use kill to remove that process entirely, right? So just like how you open Windows Task Manager to kill something off, this is a way you can like kill stuff in Linux, right? So so the command is, let's just do PS once again. Sleep is still there. Now let's kill sleep, right? Kill S sig kills like thing sig kill, and the PID is 1080. Now you do PS, sleep is no longer there, it's killed, right? This is a shortcut. This is what people usually use, is kill 9. It's equivalent to kill as sig kill, right? So you do, let's just do that thing again, sleep 10 and PS. So now sleep is there, 1085. So now let's do kill 9 1085. PS, sleep is killed. So this is very useful, kill 9. Each time you get stuck with something, the process keeps like running in the background, you can't get it done with, you can do sleep. Top is another useful command which basically says like what is running and like what is the PID and stuff. Like it even like it doesn't show, it shows like which user is running and stuff like that. It's more it shows more context and more information, and it's also useful to know like which PID and stuff like that. Anyways, cool. Let's just clear the terminal. So top PS, it's useful in that way. And there's also something called stop. Like, okay, let's do sleep again. Right. So now it's basically sleeping. So it's waiting for 100 seconds. So I can't like I can type something, but like it won't be like the prompt is not come again. Right? So you can use Control C, and that's an interrupt right now. Let's see what happens. So that thing is gone. It is like killed, you can say, using Control C, right? But let's do this. Sleep is still there. So the difference is Control Z is it's used to stop that particular process. So if you look at jobs, so it says this is a stop job. So currently there's only one stop job. So I can do like BG1, and now you look at PS, sleep is continued once again, right? No, sorry. Sleep is continued once again. PS, you can't see the difference because it's there either way. But here you can see jobs, sleep was stopped, but now sleep is running. So jobs is like used to see like whether a process is running or it's stopped or something. And now it's like running, and that stands for, BG stands for background, so it runs in like the background. If you want, you can put it to foreground. So now it's put into foreground. Now it's basically just like earlier, like the prompt does not come back, right? Because it's running. The only difference with BG and FG is that BG, the thing is running in the background. So sleep 100 is running in the background, but the thing is Sleep is a very interactive program, right? So like you can see when sleep is running. So even though it's running in the background, we can't see, but when it's running in the foreground, it's very easy for us to see. And now if we do it, now if we do jobs, there's nothing. Like there's no job because it killed it, right? Or let's just do sleep 100 again. Now let's stop it. Control Z is used for stopping, right? Now let's do jobs. So let's start. Now let's do jobs L, jobs list. Or we can see like the process ID. So now you can use skill 9 and 1009. Sorry. Now we can do jobs. It got killed, right? Yeah. So like there's a good way to do job, but job is a very, very, very sort of minimal thing. There's like more complicated things such as key marks or like GNU screen and stuff like that. If you're interested in it, I'm not going anywhere near that because it's beyond the scope of this. So, all right. So you might have run like C programs, or like you might have run like C, like you might have run some program and you might have seen like, okay, process exited with. Or like you might do like return 0, return 1, right? In your C programs, your C++ programs or whatever. So 0 means that it was a successful run. 1 means that, okay, there was an error, right? And so these are like exit codes. So you might want to learn exit codes. I'm not going to go over them because like there's too many exit codes. But yeah, Control C will give you 130. And if you use like kill 9, then you'll get like 137. And yeah, you can only have like, I think there are 255 exit codes because after that it gets out of bounds. So yeah. Okay. So now let's look at ampersand, right? So ampersand is basically a way of telling that if a particular command, if the first one succeeds, then run the next one. So let's like create a file touch here, and let's just do this thing called date. Okay, it basically gives the current date. So if you do echo date, gives you the no, echo date is basically, it doesn't work that way because it takes date as a string and not as the command. But I think date in itself prints output. Yeah, okay. So yeah, so date in itself gives the date. So if you do like, I think we already discussed this. Yeah, so if you do date here, right? Now if you go to here, it gives a date. So it's basically adding it's overwriting here with the value of date, right? So now let's say we'd like to do this in a single command, right? So the way you can do it is, let's just delete a here first. Here, now let's do touch here, and then ampersand date and here, right? So the way this functions is, if touch here works, then it would do this, right? And there is an opposite of this as well. This is basically if it fails, so like this, right? Now let's just look at cat here. It's 11, 15, 35, right? Now let's just do this once again, and let's do cat here. It's still 11, 15, 35 because the second thing never got executed. Why? Because touch here always succeeds. So it does not it does not run the next one. Cool. Also, maybe I'll just go through this touch here. No cat here. So touch does not create a file if it already exists. So that's why like it did not create an UMT file each time we ran it. So also, if you want to like run things regardless of whether one succeeds or not, you can always use this semicolon. Now let's try this. So the time has changed, right? Yeah. So if you want to run like commands inside commands, you can always do like for example, like echo date, and you want to do date, like echo date is date, right? But if you want to, if you give it like this, right? Uh, I think I should back. Yeah. So what's happening is that whatever comes inside this dollar parenthesis, it gets evaluated first, and that value is passed to the uh, other command. Like it can be wherever. It doesn't have to be at the end or something. It can be wherever, right? It can be like this. Bash is very like easy to like play around with, right? So yeah. So now what's the time? 11:17. So I'll just go through curl. Right, so curl is basically this command which you can use to access stuff on the internet. Right, so you can be like curl http, sorry. So it gave me like what's the output of google.com, right? So it says that it's a redirect. So I'm not going into what redirect is. 301 basically is a HTTP code for redirect. I'm not going there. But curl by Nate. So redirect is basically like, let's say you go to a URL and the people who host that particular URL, right? So Google in this case, Google says that, hey, this particular URL does not exist. It has moved to this particular domain. Please go there. So it's saying that it has been moved to this particular thing and it'll automatically move you there. So curl is basically uh, a program used to access a particular web resource or something. The program is designed in a way so that it acts like a Linux. It's very Linuxy or Unixy, as in it is a very stream sort of program. So like I don't know if you might have observed, but like you can sort of in Linux, piping and like taking things together and joining together is a very useful thing. So like curl gives an output and you can pipe the output to like bash or like grep or like whatever you want, and like pipe it and chain it so on, so that you can manipulate it further. There's another tool called wget, which is what people usually use if you do not want to like chain and stuff like that. Curl is a bit more primitive but a bit more Linuxy way of doing things, right? So yeah. So the thing is, now I gave curl hyphen capital L, right? Yeah. So L is basically a flag used to allow redirect. So this has now given me like the output of google.com. So if you go to google.com, it would give this, right? Yeah. And now basically you can redirect it elsewhere. Like, okay, sorry. And you can say like, hey.txt and yeah. Now let's look at. So it has saved the whole thing onto the hey. Basically, only thing I did is I took the output and then I overwrote the hey.txt file. It's just like all the Linux commands we saw, right? So if you want, so this thing called, like, you might have heard of this thing called Docker, right? So there's this thing called get docker.sh or something. A lot of programs, to install something, you might have like shell script or something, right, on a particular website. So like, let's do this. Excuse me. Let's do curl and let's paste this thing here. It's basically um, like it's a shell script, right? It's a .sh, so it's a shell script. Now, if you let's just look at this dot get docker.txt, right? Now let's just do less get docker. Wait a second. Right. So there's a lot of these things. Uh, but okay, I don't know what this means. But like, I think I went to the wrong URL. But like, my point is, you can do things like this. I don't think that's the URL. But if you give things like this, then what it'll do is it'll take the output. Like it is a shell file, right? So it'll take that and it'll run it with bash. So you don't even have to save that file. So with curl, you can take like the output and like pipe it and chain it and so on. It's very beautiful. You can do like a lot of cool things. I couldn't show the thing. Maybe this is a game if I'm not wrong. I'm try getting that. Just a second. Okay, so there's this game that I got from the internet. Let's try it out. I'm not sure whether it'll work. Yeah. So now, okay, I don't know what game it is, but it's trying to do something, right? So, like, this would have worked too, right? Like, as in if I give like, let's see. It doesn't have execute permissions. It's the problem. So it doesn't have execute permissions. Let's give it execute permissions. There's something called chmod plus x, which is a good way to give it just execute permissions, and you don't want to worry about other things, right? Right now, let's try .game.sh. Okay, I think there's a game called 2048, but yeah, whatever. No, I don't really care. Cool. So like that's the thing. Like in Bash, I mean in curl, you can take it's a very stream-based thing. Like you can take an output and you can pipe it to the next thing. Cool. Now let's talk about package management. So yeah, just remember these things. Curl and duplicate. I didn't talk about duplicate because we're running out of time. It's a bit more heavier tool, I'd say. I mean less Linuxy thing rather. Cool. Now let's talk about apt. Sorry. Right. So apt is basically a package manager. So what is packages is the first thing that you have to understand. Packages is similar to like your app store or like your Play Store or like your Windows Store. So the only difference is that it again follows a very Linuxy or Unixy way. So it has like one thing, like more like you can sort of imagine like libraries. For those who have used like Python or like JavaScript, you might have encountered pip, or you might have encountered npm, right? So this is sort of like libraries, and you bring libraries together and you bundle them together, and you get a like fully fledged package. So you have like you can sort of imagine like you have different components and you assemble those components together and you compile it, or like you have that binary and then it functions together. So that's how packages works in like Linux, and each distro has its own package manager. For example, Debian has something called dpkg, right? So that's the Debian this thing. But because Ubuntu is based off Debian, dpkg would work in Debian also. And apt is like based on Debian. It's called advanced, I think it's called advanced packaging tool, right? So like you can do like sudo apt install like any package like MySQL. It's like a database, right? So it's like installing MySQL. Okay, there's no package called MySQL, possibly. So let's do sudo apt search MySQL. It's basically searching, right? And now it's saying that these are the things related to MySQL, and now you can basically select the one that you want. There's something called Akonadi backend MySQL. So you can like install that or whatever. Like you can install whatever you want using apt, like sudo apt search Python. right? So it shows like a lot of things related to Python, and you can install that using sudo apt install. So like I think it's, yeah, whatever. So you can do like sudo apt install python 3. Yeah, so it's already installed, so it doesn't do that. Let me, yeah, so Red Hat has something called RPM, and there's something called Yum in like Fedora, CentOS, and all. And like different distros have different package managers rather. But it's just like sort of Play Store or App Store. There's something called Snap, which I think is built onto Ubuntu. Like this, I'm running Ubuntu right now, so Snap is there. But you might have to install it on other distros. But the thing about Snap is it can be installed on most of the distros, and it is self-contained. It is like your App Store. It's like your uh, sorry, what is that? Play Store or whatever. It's a self-contained thing. Whereas in like apt or normal like package managers, it's like component based. Like you should have all the components, and then the component can be shared across different. Like let's say you have package A, let's say you have package B, and let's say you have package A, and then let's say you have two other packages called packages B and C, and package B and C both depend on package A. Then if you're using like apt or something, apt is clever enough to understand that okay, both B and C share A. So now if B is installed, I don't need to reinstall A because A can be shared between B and C. But there are problems associated with it. Like for example, one version might be not compatible with this or things like that. So which is why it's better to have, it's not better, it depends on your use case actually, and apt is like really clever and advanced to like resolve the conflicts or dependency conflicts and stuff like that. But yeah, Snap is like sandbox, so it's like safer, and they cannot like you know how just like how every single app in like your Android or like iOS is like sandbox, like they cannot break, like they cannot access things outside a particular folder. uh like if you have things like like deb file or like apt package, they can do whatever they want. So like if you install like a malicious script in that package, it can run what, like if you give it the right privileges, if you like with like sudo privileges, it can actually do whatever it wants, and snaps update automatically. So otherwise you have to do like sudo apt update each time you want to update it. This is actually updating the repositories, right? If you want, like I think you have to do sudo, right? Sorry. um yeah, and I mean let this get completed, and you can also like, it's very easy to like install applications from Snap, and there's also like a GUI app store called Snap Store if I'm not wrong, and it's just like the app store or whatever. Cool. Okay, so now I've completed most of the bit. You can, okay, so like if you want like you can do sudo apt upgrade. I'm not doing this because it'll take like forever, and that's how you can upgrade, right? Cool. Yeah, so for this I think we have more or less covered most of the introductory Linux ecosystem. You can write your own shell script. It's not intimidating, but I'm not going there because in its own like different way of doing stuff, but it's very easy, and I'll probably link resources to the same. Yeah, also understand that the shell is very customizable. Like the prompts, which is basically this thing, can be customized quite a lot. Like if I go to like my default shell, right, it has its own prompt, right? Like it says it took this much time or whatever. Now like let's go to cd.files. It's saying like dot files on master, whatever. It's basically like Git. So this is a Git repository. If you don't know about Git, that's completely okay. And for those who would like to know about Git, there's like a FOSS MEC workshop happening today. But it gives me more context, as in like dot file is on a master branch of Git, right? Like similarly, if I go to like, mm, I don't think I have a Node.js thing. Let's just check this. Yeah, it's not Node.js, but it gives me more context. You can customize like a prompt and stuff. Like this is a more fancy prompt, right? And you can also customize colors. Like I have customized my colors and stuff, and you can install themes and stuff based on your shell and all. It's very customizable, and like I don't know if you might have observed, but like why this thing is like transparent and all that. That's based on the terminal, right? So yeah, like you can customize your shell and terminal to whatever degree you want. Yeah, I think we've come to a close and we can possibly wrap this. And if you have any sort of uh, questions or doubts, please do put it up here so that I could clarify. I'll also be sending in some, maybe in another 2 or 3 days, I'll send some links and a compiled set of links and things you can go through to advance your knowledge. Mm. There's like a lot of fun programs too. Like if you do lolcats. Mm. Right, so it's basically like rainbowish. There are a lot of fun programs, like a lot of small, tiny games and stuff like that. So, any doubts or any clarifications, any feedback, welcome in any way. Yeah, also like there's this amazing tool called Git, and you should definitely learn the thing if you're interested in development. I think we could wrap the session probably in that case.
Yeah. Okay. Now we have come to the end of the session. Mixed Signals extends a heartfelt thanks for your illuminating presence, Varun, for spending a part of your precious time to share this valuable knowledge with us. Participants are requested to fill out the feedback form before they leave the meeting. Thank you and have a nice day.
Thank you for having me. Thank you.